Okay, so in this section, polynomial division, the remainder and factor theorems. So when we discuss in previous section to plot the graph of a polynomial, you need to find the zeros, and for finding the zeros, you need to find the factors. And one tool we can use to find that factors is using division. There are different ways to divide. One is long division, which is the normal one, which we know up to now. And in this section, I'm going to talk in detail about this synthetic division. That's the efficient one. So for example, let's say you have a polynomial x squared minus 2x plus 1, and you would like to divide that polynomial by x minus 1. So the long division is what you do. You just divide the highest degree term here, which is x squared, by the highest degree term here, which is x, and whatever comes, that goes on the top here. By doing that, now what you do, you multiply every single thing here, which is a divisor. This is called divisor, by x. So x times x is x squared. X times -1 is negative x. Now you change the sign of this because we are subtracting. So if it's plus, make it minus. If it's minus, make it plus. And then try to combine these two lines. So this is cancel out. That is the main idea. And then the remainder is negative 2x, positive x is negative x. And then, bring everything down, which is plus 1. This thing, this is the, remainder. If the degree of this thing is equal or more than the degree of this divisor, this is called divisor. Remember, this is divisor, this is dividend. This is what we would like to divide by this one. So if the degree of this thing, the leftover remainder, is still same as degree of divisor or greater, then you continue this process. In this case, the degree is 1 and the degree is 1. So take the highest degree term, which is negative x, divide by the highest degree term of the divisor, which is positive x. If you do that, you are going to get -1, and just copy that thing here on the top. This place is called quotient. This place is called remainder. The place, not the place, the value is called quotient here. Okay. So now repeat the same process. Multiply each of these term of the divisor by -1. So -1 times x is negative x. -1 times -1 is positive 1. Now after that, change the sign. So it becomes positive, it becomes negative. Here is the -1 and here is the positive 1. So cancel out, cancel out. And then leftover would be 0. So 0 remainder, and this one is called quotient. So this process is the long division process. It takes time, but this is the long division process. I don't want to use the long division. Whenever it's possible to use another method called synthetic division. And I'm going to show you how to do the synthetic division, okay? So division and factors. When we divide one polynomial by another, we obtain a quotient. In our case, in our example, when we divide this by x minus 1, we got x minus 1 on the top. That's the quotient. Let's denote this by q of x. Q of x means quotient. And after doing the operation, after some time, we got the leftover at the end. That's called the remainder. Let's name this r of x. Okay. So what happens is any polynomial dividend, which is on the top, in my example, the example I'm using, p of x is x squared minus 2x. Okay, x squared minus 2x plus 1 is equal to divisor, which is x minus 1, times the quotient, which is also x minus 1. That's what we got here on the top, x minus 1, So, and then plus a remainder. In our case, it's a 0 is the remainder. Okay, that's how we write. So according to remainder theorem, if c is substituted for x in the polynomial of f of x, like this is the polynomial, and if you put x equals c, then remainder would be equal to f of c. So f of c is the remainder that would be obtained by dividing f of x by x minus c. Okay, so if this is the remainder theorem, let's say you have a polynomial f of x and then you want to divide that polynomial by x minus c, then remainder of this would be f of c. That's the remainder theorem. And the factor theorem says if the remainder is 0, then x minus c is a factor of the function. So in our case, the example I was giving you here, the remainder is 0. That's the reason x minus 1 is a factor of this dividend. Okay, so a couple of things you have to know how to divide. That's the first thing. What is remainder theorem and what is factor theorem? And I'm going to use some example, at least one example to show you how to do the synthetic division. So let's go here, use the synthetic division. Let me just use it here to divide this thing, a dividend by divisor. So this is not the long division. We would like to use synthetic division. So first of all, write down the dividend from higher power to the lower power. So it's start with x cubed and then 2x squared and then whatever you have. The next degree is supposed to be 0 times x because there is no x term. So I'm going to use that as I can also write it down as a 0 times x, no problem. So you need every single term plus finally there is a 9. So there is this thing missing. So whatever term missing, you just put 0 for that. So now after that, just copy the coefficient of each of these terms. So in front of x cubed, there is nothing. So the coefficient is 1. In front of x squared, the coefficient is -2. In front of x, there is 0 because there is nothing. And then last constant is -9. So now just do this. And look at here, x plus 2. You are trying to divide by x plus 2. So if it's plus, then make it minus. If it's minus, then make it plus. And bring that number here. Okay. So this process is called synthetic division, and I'm going to show you how to do it. First of all, you need to write down the coefficient. And then c means in this case it's a -2 properly. If it's plus, make it minus. If it's minus, then make it plus. So first of all, bring this 1 down here. Let's just copy it here. And now multiply this -2 and +1. -2 times +1 is -2, and that goes here. And now combine them. So that is -4. And do again the same thing. Multiply this number, whatever you get here, by -2. So -2 times -4 is +8. That goes here. +8 plus 0 is 8. 8 times -2 is -16. So if you add this, that is -25. Okay? Make sense? So that is -25. Okay, so now what do you do next? You okay, so the next is from here we are done. We don't have to do anything else. From here, the last number, whatever you get, that would be the remainder, and then the rest of the number, that will give you the quotient. How do you write the quotient? You start from this last number, which is a constant, put it the sign, and then next number would be the coefficient of x, and next number would be the coefficient of x squared. So this is your quotient. This is the quotient, and this is the remainder. So when you divide this by x plus 2, this is what you are going to get as a quotient, and this is what you are going to get as a remainder. So in this problem, the quotient is x square minus 4x, and then let me check, plus 8 and plus 8. So that's the quotient, and the remainder is negative 25. Okay, so let me just do another problem. Where is that? X plus 5, always x plus 5. What is that? It's not giving me something else. Okay, it's not changing, so I'm going to do question number 5 one more time. Copy the coefficient of the dividend, each term of the dividend. If you see any term is missing, just put the 0 for that. In this case, nothing is missing, so I'm going to copy 2, negative 4, negative 1, and negative 19. These are the coefficient of x cube, x square, x, and then constant. And then the number comes from the divisor. Here there is a plus sign, so make it minus 1. And then bring this 2 down here. So 2 times negative 1 is negative 2. Combine this, negative 6. Negative 6 times negative 1 is positive 6. Combine this, positive 5, and that would be negative 5. Combine this, again it's a 24. This is the remainder, and rest is the coefficient of quotient, and this is the quotient. So q of x is 2x squared minus 6x, 2x squared minus 6x plus 5. That's the quotient, and then the remainder is negative 24, sorry, negative 24. Okay, for finding the value of f of 4, just put x equal 4 here, and then you are good. I'm not going to do that for you. Just put x equal 3 or 4, whatever, and find the value. The quotient is, what is that? Use the synthetic division. It's x minus 1. The remainder, that's the same problem. Find case such that x plus 4 is a factor of this. X plus 4 is the factor, so there is no remainder. How do you find that? So if something is a factor, then remainder is 0 from the factor theorem. Let me just... Okay, x plus 4 is the factor of this, so that means the remainder is 0. Remainder 0 means when you put, let's say f of x is x cube minus k times x square plus 4x plus 19k. So f of negative 4, because when x is negative, this becomes the 0. So negative 4 is a 0 of this factor. And if it's a factor of this polynomial, then negative 4 is supposed to be 0 of this one too. So when you put negative 4 here, that means so when you put negative 4 here, that would be negative 4 cube minus k times negative 4 square plus 4 times negative 4 plus 19 times k. When you put x equal negative 4, because negative 4 is the 0 of this factor, and this is the factor of the polynomial, so negative 4 is supposed to be the 0 of this polynomial. So that means when you put negative 4, this thing is supposed to be equal to 0. So do the simplification here. Negative 4 cube is negative 64, and that's 0. Negative 4 squared is 16, so negative 16k. Here it's a negative 16, and here it's a positive 19k. So we are trying to solve quadratic equation here. Not the quadratic, linear equation here. So combine this, AD minus plus 3k, because negative 6 Negative 16 plus 19 is 3. So bring this negative 18 to the other side, positive 18. So that will be 3k equal positive 80, and then divide both sides by 3. So that would be your answer. 80 over 3 is the value for the k. And that's a simplified fraction. And that can be done because we know x plus 4 is the factor. And if something is factor, then the value of the f of c is supposed to be 0. Where c is coming from here, since there is a plus sign, you have to make it minus. That's all for this section.